Thank you. Thank you. All right. Well, good morning, everybody. My talk today is going to be on stopping attacks in Kubernetes using a product called Tetragon. Before we get started too far here, I'm sure you're wondering who am I and why should you care about what I think. So I am Richard Wilhite. I am a security engineer at Splunk, which is now part of Cisco. And I've been doing various technology things for the last 20 plus years. Everything from desktop support technician to now security engineer. And I'm Kansas City native. I grew up in Baser up north. And right now I live in Lawrence for the last 10 years. Now, if you want to reach out to me after the conference with any questions or any follow-up things, you can find me on LinkedIn up there, which you can probably find easier on the video afterwards. Or I'm LFK Rick on CISO's Discord. And then finally, we've got this little bee down in the corner here. That is EB, and she is the Tetragon mascot. If you want to find more fun pictures, there's plenty throughout the presentation, but there's actually an EB Dex out on ISOvalence GitHub page. You can go and read all sorts of fun stories about EB. All right, and what we're going to be talking about today, we've just got a few sections to go through. First up is the detection gap, which is just the delay between detection and enforcement, kind of piggybacking on what Tim talked about in the talk before here. And then we're going to talk about some of the other tools we've got in the space today. Then we'll move on to how Tetragon works and talk about the three pillars of enforcement. Tetragon does a lot of things. But really, day to day, we focus on three main areas. Then we'll try to do a live demo. We'll see how that goes. And then finally, follow up with some best practices and resources. So what am I talking about with the detection gap? This is, again, aligning with what Tim talked about in the keynote. It's the delay between detection and response. Now, some of the popular tools in Kubernetes for security today are stuff like Falco and Tracee. And they do a great job of alerts, and then you can, from those alerts, triage, enrich, investigate, respond. But all of that takes time. And like Tim was talking about, the time that we have to respond keeps shrinking farther and farther. We used to have a CISO at Splunk, Jason Lee. He was a CISO at Zoom before Splunk, and he challenged us to have a response time of less than 7 minutes. And that was tough. We really struggled with that. And in today's landscape with AI, I think that 7 minutes is going to continue to compress. And so being able to respond quickly is really key to protecting the environments from threat actors. If you don't respond in time, you've got people in the environment who have already pivoted laterally, escalated privileges, they've exfiltrated data, or they've harvested credentials. So if you have to detect and respond, you're betting your environment on the size of the gap and the speed of your SOC. Modern runtime security has to collapse that gap with policy-driven inline enforcement. That's just better than just alerts. So again, I mentioned in the last slide we talked about Falco and Tracee. These are not bad tools. I don't want you to think that I'm saying they're bad. They're actually really good at what they do. Falco is a great open source library. A lot of times when you've got zero-day threats that come out, the open source community has detections out in Falco within the same day. You can deploy Falco very quickly. A lot of times for teams, especially smaller Kubernetes infrastructure or security teams, Falco is the fastest way to get baseline security visibility in your clusters. Tracee, for its part, provides really rich telemetry. It's great for forensics and gives you process file, network stream events. It's great for finding out what happened after the fact. It also gives you a mountain of data. And, as someone who works at Splunk, I do know a few things about mountains of data. So while the Tracee data is great, a lot of times I think what it leaves you with is you end up being data rich and knowledge poor. After the fact, you can go find out what happened, but you're still in the news. So not exactly what you're looking for. Both these solutions are detect only, and they can tell you, suspicious process just spawned, a container is touching a sensitive host file, or there's an unexpected outbound connection. But neither of these can block. So Tetragon, by contrast, is a rich observability solution, but it also has enforcement capabilities. So we can both log suspicious processes, but also block containers from reading and editing critical host files, or stop network connections out to command and control infrastructure. So Falco and Tracee do a great job of helping you understand what went wrong after or as it happens, whereas Tetragon helps close the detection gap instead of just shining a light into it. So how does Tetragon work? So at a high level, Tetragon is a per node agent, a cluster level operator, and then custom resource definitions. So for the agent, it's a daemon set on each node. It attaches eBPF programs to kernel hooks and provides Kubernetes context for those events. And the Kubernetes context is really one of the things that it shines to provide. That context helps identify where those connections came from. It'll give you the pod, the namespace, the cluster, the node, and helps you narrow down where your threat actor is activating, malware or harvesting credentials, whatever you want. Since it's eBPF, it's got visibility in both kernel and user space, which gives you great visibility across your clusters. Then the operator manages policies. So the cluster level policies are the operator pushes those to the agents, and that offloads some of the compute of the agents so that the agents can be as performant as possible on the nodes. Now, the policies are just normal Kubernetes primitives. So we've got tracing policies or alert rules or a couple of the type of custom resource definitions that Tetragon uses. The tracing policies tell Tetragon what to monitor and how to enforce, and alert rules provide a higher level security context. Those would be what you'd send out to the SOC to respond to. But the key point is that those policies are Kubernetes native objects, so you can manage them by applying them to your cluster the same way you would any other Kubernetes resource. So while Tetragon does a lot of things, in a day-to-day, when we're running Tetragon, what we end up doing is focusing on three areas: file system, unauthorized file system access, privilege escalation, and then suspicious network connections. So when we talk about unauthorized file system access, these are things like reading etc shadow or its passwd on the Kubernetes nodes, dropping binaries or script into temp. I don't know if anybody had to work on a trivia incident here lately, but it kind of might sound familiar. Or modifying system configuration files to establish persistence. Now, if we look on the right-hand side here, that is really hard to read on the screen. But I tried to share an example of a tracing policy. Hopefully it's easier to see on the video, so I'll just talk to it and you can follow up later if you'd like to see it better. The main thing we've got here is, so we're using a kernel probe. In this case, we call it a K probe. We're looking for a syscall for opening a file, the sysopen that. And then we were matching our arguments. We're going to look for the etc shadow file. And then finally, we're looking to perform a couple actions here. We're going to post, which means we're going to log the activity. We're also going to sig kill. We're going to block the process that's attempting to access the file. So the second pillar I talked about was privilege escalation, and these are things like invocation of tools like nsenter or chroot, attempts to join host namespaces, or sudden capability changes like gaining cap sysadmin. Again, I've got a tracing policy that I'll do my best to talk through here. So again, we're using a kernel probe, and while I've got K probes up here as the examples, you can also use U probes if you want to inspect user space activities. But we're looking for the set NS or set namespace system call. We're looking for just a couple of binaries here for NS enter, located either user bin or bin. And then again, we're going to log the activity and kill it. So finally, we've got the network, suspicious network connections. So these are outbound connections from pods to known command and control infrastructure, processes that should be local only that suddenly initiate outbound TCP connections, or lateral movement inside the cluster, pods that shouldn't be talking to other pods. Now, this tracing policy, we've got a couple more things included here. Again, we've got a kernel probe to look for TCP connections. We're limiting it to just look for curl in this example, but most of the times when we're honestly doing network connection monitoring or alerting, we don't typically add the binary in there. You could leave that section totally out and monitor for everything that goes to those connections. And then finally, we've got a couple of IP addresses that we're going to monitor for, and we've got our action to sig kill. So in this example, we've got specifically 2 destination IP addresses, and there's a lot of options for what you can do there. You can use source address, destination address, CIDRs. This is just one example. There's a lot of options. Now, one other thing I want to point out is, since this is a normal Kubernetes primitive, you can use normal pod selector or namespace selectors that you would in any other Kubernetes deployment. So you see here, I've limited this to just a single pod named Xwing. And I think that's one of the great things about the Tetragon policies is your ability to just work them in to specific areas in your environment. All right, so now we're going to try to do a live demo. We'll see how this goes. But essentially what we're going to do is we're going to install Tetragon in Minikube with Helm. And I know a lot of you are probably thinking, well, Minikube installations are a lot easier than an EKS cluster or an AKS cluster. And you're not wrong, but actually I've had pretty good luck with installing Tetragon on EKS and AKS and GKE clusters. So I can tell you it's not much more complicated than what we're going to be showing today. Then we're going to execute kernel out to a malicious IP address and then try to block them. So, and then I got to try to type in that too, so it's fun. Well, he's going to help me out.
Have him type.
All right. And then, no, you're good.
It's for them, not you.
Okay. All right, so hopefully you guys can see this okay. So first off, let's check that we don't already have Tetragon running. Make sure I cleaned up my Minikube instance, okay? Yeah, so we do not have Tetragon there at the moment. Let's install it.
This madman doesn't have the shell on his screen, by the way. He is straight up staring at here for y'all's benefit. So give him some love real quick.
Sir, can I do a favor and get you a chair?
No, because then I'm blocking. It's all good. Appreciate it. I ain't that old yet.
Let's try this.
Sure. Yeah, that's probably easier, right? There we go.
All right.
Now I can see too. He's just mumbling. It's fine.
There we go. All right. Now we should have Tetragon installed. Let's check that out. Yeah, so pods are coming up there. We've already got a Tetragon agent right here. And then we've also got a Tetragon operator that's going to come online here shortly. All right, they're up and running. So let's see if we can find some logs. That's not the one. Right. I have to use pod name.
Stupid non-deterministic pod.
All right, this is going to be great.
I'll be fine. I'll find it. I'll find it.
Not found. Oh, command not found. Hold on. Do you need a flag to say the pod read? Well, identical to what it was above. I was about to say, get the new line.
Indeed, I am.
Yep.
There we go. Audience for the support.
Yeah.
Appreciate it. All right, cool. Now we're getting some logs. All right. All right, so let's go ahead and try to do a curl command out to our malicious IP address. That's the old one. There it is. There we go.
Hey.
All right. Yeah, so there we got our IP connection out. And it's a little hard to see, but there, over on the side there, we did see a curl command. Let's try something else here. Because since I sized up the screen a bit here, they go by fast. All right, that's a little bit better. So we can see that we had a bash process fire and a curl command underneath that. And then we can also see that it exited with a successful 0 exit code. All right, so now if we wanted to, say we had the SOC come along and say, hey, we see this IP address connecting out, we want to understand what's happening with it. We could deploy a tracing policy. We can look at that here. And this is just the same tracing policy I was showing in the example on the slide. You can see that we're limiting it to the X-Wing pod for this demo, TCP connection for curl out to some IP addresses. And in this example, we've got a SIG kill as the action, but you are probably not going to want to start there unless you really hate your developers. But and I mean, then have fun. But what we'll start here is we'll go ahead and comment this out. And then we'll add a post action in here. That way we can just log the activity to start. Now again, since this is just a Kubernetes primitive, we can just apply it like normal. So, okay, apply. Yep. So now we've got a tracing policy in place. So if we do our curl command again here, except for I'm grabbed for curl now, so we don't see my example. Awesome. We'll see if we no, it's not there.
Yes, yes.
Get rid of that. All right, now it's going to go by really fast, but we can see now that we've got a TCP connection there out to IP address. It shows the source and the destination IP and the source and destination port. So we got a little bit more data to work with. All right, so the SOC says, hey, great, we can see those connections. They're really bad. Please block them immediately. So we can go back to our tracing policy now. And we can say, all right, we got a bad thing. Let's kill it. And the great thing is we can just, where's my plug? We can just apply it over the top. So it's going to update the tracing policy. You don't have to delete the old one, you just reapply and it's going to overwrite. Now it does take, when we go to SIG kill, I've been seeing about 30 seconds for Minikube to pick up the policy and push it out here. So we'll see how fast this works. Still there. There we go, it got killed. So now we can see over on the right-hand side.
Yeah!
Up there. We can see over on the right-hand side there that it's going to go by fast. We SIG killed the process and it's should have an error code instead of a successful command return. Cool.
Yeah, you can take that back.
Right. Thank you to my microphone holder. Slide. Cool. All right. We survived. So some best practices. Obviously, what we showed in the demo there was you usually want to test before you go into enforcement mode. Like I said, unless you've got a really bad relationship with your developers or you really hate your job and you'd like a resume generating event. Definitely best to test visibility before you go into enforcement. The nice thing is it's really easy to flip those switches and deploy the enforcement policy. So it's not a huge lift to move from one to the other. My second recommendation is definitely do CI/CD integration. So this is probably something a lot of you are already doing if you're working with Kubernetes. I doubt it's anything new to you. But at least what we do at Splunk is we have a pipeline that deploys the Helm chart for Tetragon, and then we have a separate Helm chart that deploys our policies. And the Helm chart's pretty simple. All it's doing is deploying the policies, but it does allow us to use that Helm logic to deploy policies to different clusters or target different namespaces on different clusters. The options are kind of endless there. And so that's just, we use a single pipeline. It deploys Tetragon, deploys our policies, and it just makes life easier. And then when we add in new clusters, again, they both get the same deployment and the same policies all in a single pipeline. And then finally, we've got the Tetragon Quick Start Guide. So everything I talked about today is stuff that you can kind of test out if you follow the Quick Start Guide. There are instructions for installing a Minikube or EKS, AKS, GKE, whatever you want to test with. And then I'll also point out, obviously, Splunk, we're part of Cisco. Isovalent is also a part of Cisco. But everything I talked about today is part of the Tetragon open source project. So you can go home and try all this stuff out today. Now, we do have a paid Tetragon enterprise product. And when that comes into play, it's like, you go out, you test it, you're like, hey, this is great, but I'd like some support or, better SIM integration or, some default policies out of the box, because open source does not have any default policies. Or you might want a systemd agent for all those virtual machines if you haven't migrated over to Kubernetes yet. That's where the Tetragon enterprise license comes into play. But I do want to make clear that everything we talked about today is from the open source. And with that is all I got. So thank you very much for coming out. Thanks for listening. Questions.